like we did in the first one with a very quick example. And then we're going to segue over to our G-code style, which is called our program guide, which is standard within the control. And then we're going to take the same geometry. I've brought it in, having it had been posted out of a CADCAM package to show you how you can handle CADCAM files quite easily at the control. And then the last thing we'll do is we'll get a chance to take a look at our ISO mode, which is a FANUC compatible mode we have within the control that allows users to import FANUC programs and actually run them in our system. We'll talk about some details and some setup functionality that would have to be done within that. Now, everything applies within this webinar series to both the 828 and the 840 control. So as we go through it and we talk about these features, whether you have or you're looking at a product with either 828 or 840, everything you'll see here can function or work within either of those two variants of the system. What we do is we try to keep everything as uniform as we can from within our full range of product offerings. So you'll notice that we have almost identical commonality from control to control or series to series. This way, if you have an operator that maybe starts on a lower end system and graduates up to a higher end system or vice versa, you don't have to retrain your staff all the time. Basically everything they know in the one area will be reflected in the other area, and then obviously advanced cycles that would be added on for maybe more advanced technology. So this is just a basic overview of today's course, Easy CNC with Sinumerik Operate Part 3. So we go through the functionality as we told you. We'll basically take each example, go through the first two. We'll physically write some programs right here within our simulator. We get a chance to simulate them, see it graphically run, and then we'll even emulate an auto mode and show you the steps it would take to physically run them. And we'll do that for all four types of jobs. So whether it be programming in conversational, G-code, importing from CADCAM, or bringing programs that were previously programmed for like a FANUC style machine. This is going to be the example we're using today, and I have a PDF of the print here that we can kind of toggle back and forth to. So as we need it, or as I go through the system, I'll jump back to the print just to give you an idea of why I'm inputting what I'm inputting, why we're doing what we're doing. But just wanted to keep it very simple. We don't need to have an overly complicated shape. Just want to show you some kind of a regular shape. We're going to contour mill this. So we'll mill around the outside of the profile, and we're just going to put some simple drilled holes in the part. And then we'll do that in all four modes. So with that being said, the first thing we're going to look at really once we get over to CineTrain is our program manager. And that's going to be the area that allows us to manage either creating or importing programs within the Siemens Sinumerik control. So we'll step in, we'll show you how to get into the area, show you the basic file structure that get made up, show you how to either create directories within the system or create part programs. We'll talk about some of the other functionality or features within it, like the ability for us to do a save setup data, which allows you to save your tool table as a separate file. So not only can you save and export or import programs, but you could potentially save your tool tables and work coordinate values as well. So that would be something that's handled under Program Manager. So we're going to start here within the Program Manager. We're going to start in Shop Mill. What we'll do is we'll step into a Shop Mill program by creating a new one. We're going to go through the basic functionality laid out and some of the steps we would take to be able to part program this basic shape. We're going to go in and we're going to go into our contour editor and draw in a regular shape, so you get to see how you input irregular data into the control, something that's not that typical rectangle or circle. Then we're going to go into graphics. We're going to simulate the physical job. You're going to see a tool come in and do a live run around the part. We're going to show you some of the other advanced functionalities within our graphics. Then from there, we're going to jump over to auto, and we're going to talk a little bit about auto and what it would take to physically run the part if we were ready and the offsets were already set up. So from there, why don't we segue over to do a live demonstration, and we can get into the kind of meat and potatoes here. So what I'm going to do is I'm going to jump over to what we call CineTrain. CineTrain is a offline system or a control program system that emulates our control. It's a little more than just an offline programming package because it allows me to do full machine tool functionality. Right now I'm looking at my jog screen. It's what the first screen I see when I come in. This software lets me jog the machine around. You know, if I wanted to pick an axis and start moving things around, I could physically jog around the machine. A lot of times when you do offline programming or programming systems, they allow you to create a part program, but they don't allow you to truly emulate the entire machine control. Here, my overrides, they're all fully functional. All of my manual panel buttons are functional. So this is really designed as a true training aid where we'll use it within our own classroom type settings to be able to teach a guy how to fully run the control from basic setup to writing programs to running them in an auto mode. So with that being said, I'm not going to spend a lot of time going through or set tools or whatnot. That we did cover in part 1. So if you missed it, you can always refer to part 1. And that'll tell you a little bit more about how to set up the machine tool. But what we are going to do is we are going to go over to Program Manager. I'm going to use the right-hand Program Manager button. And that's going to put me over to the area where our part programs would reside. So when I come over to Program Manager, I see 3 main folders. I see part programs, subprograms, and workpieces. And the way this is designed is I can create subfolders if I want to start creating subfolders under my workpiece directory. Like I have this Modern Machine Shop program directory where I created some of the sample programs that we use for today. I have a part program folder. If I want to just do basic part programs and I'm not worried about putting them in some subfolder, I can use there. Or if I happen to be creating subprograms, I can categorize them or group them under the subprograms folder. Within that, I can use my lower horizontal keys to kind of navigate a little bit through the control. I can look at a local drive would be an internal directory that's maybe expanded part storage within the control. You have this local drive button, and then you could do the same functionality here, creating part programs, running them from here. I have USB. Every machine comes standard with USB. There'll be a USB plug somewhere situated typically on the front panel of the machine. If you were to plug a USB stick in, the USB function would become black, and I could then immediately click it and activate it. And then what I did over here is I have it labeled as a local drive because it's local to my laptop, but typically this is how a network drive would appear. So if you're using a network system and maybe you want to go out to some folder outside the system, you can do that by clicking either the network drive or local drive, however this custom button was mapped, and you can do multiple custom functions. And then in here I can browse to a specific folder. I created a program directory here where I was starting to put some of my part programs. So I could come over to any one of the directories. Like in this case, I have this Modern Machine Shop webinar directory, and you can start to look at some of your different files. So we'll explore some of these files in the later sections of the webinar. As well with that, I can use my cut, copy, and paste commands on my vertical side to grab a file, maybe make a duplicate file of it, or I want to cut one, maybe move it to another area. If I expand my vertical soft keys over with my arrow, I can come in, I can do, under archives, I can do my saved setup data function. This allows me to save tooling data. We have a multiple clamping function. This allows me to take a single program and then array it over multiple vices, and it will automatically methodize the part for you and run that one part program on 2 or 3 or 4 or 5 different vices, basically as many as I'd like to set it up for. And then you have properties. You can go in, you can maybe change the name of a folder, change the name of a file, set up privileges to files if you want to restrict how a file gets accessed by different user levels and whatnot. So there's all sorts of different capabilities within Program Manager. But for us in this first case, we're going to come in and we're going to create a simple shop mill program machining this part. So again, just to look at it real quick to refresh your memory, this would be our basic shape that we're going to come in. We're going to come and create a 1¼ end mill or base mill or whatever we want to use. And we're going to roll around the outside, maybe take a couple cuts to profile this shape out. And then we'll jump over to a 1/4" drill and we'll drill these 4 holes. So first I pick a directory. I'm going to use the part program directory. Then I'm going to select new. New is going to give me the option of telling it what type of file I want to create and give it a name. So I'm going to create a shop mill program, and I'm going to give it some basic name. So I'm going to call this, we'll just call this sample 1, and I'll say shop mill. Okay. I type in a name or number, it doesn't matter, say OK. It's going to launch me into our conversational area. From here, you fill out this first page. First page allows us to tell the system what work coordinates I'm using, What is my blank for graphical purposes? Is it a block? Is it a hex stock? Is it a cylinder? Is it a pipe? Is it a basic block with the center of being 0, 0? You fill out the values. Here when I'm defining the block, I'm just defining two opposing corners. So in this case, my upper left-hand corner I'm going to treat as basically 0, 0. I'm telling the system I have a little bit more material from the part, saying that the part's a little oversized, so I'm giving it 1/8 of an inch on either side of the part. That's why I gave it a -1/8 of an inch here, and then my overall finished length is 4 inches, so I'm going to give it another 1/8 of an inch on the X side, and then some length and some thickness. Define what plane I'm in, my retract location, my safety distance, what I'm going to wrap it to. Once you've filled out the page, you may hit accept. Now we're going to come in and we're going to define what we want to do. So our first step is to go to Contour Mill and create a shape, whereas we're going to mill the shape first. So step one would be go to New Contour and give it some kind of name. So I'm going to call it my profile. I type a name. The name is just for your reference. It has no bearing on the functionality of this profile. And then we come into our contour editor, and I can start to type data points to physically draw the shape. So here I'm going to use my upper left-hand corner to be 0, 0. So I'm going to tell it I'm going to start there. And now I'm going to walk around this part. So if I want to climb mill, my first move, I'm going to want to walk around a clockwise direction. My first move is going to be an X move. And looking at my print that I have in front of me, I see that my line is moving over to a value of X 2 inches. You type the value, you hit accept, it immediately draws a line. Then from there, this part happens to sweep into a big arc. So I'm going to pick my arc event, define the direction of my arc with this little direction rotation. I'm using the select key whenever I need to change a field. I'm going to give it some radius, which happens to be 1.5 inches. And now we're going to give it an endpoint of the arc. Now, depending on the data I know, if I don't have an endpoint but I know a center, I can give it that, or if I know an angle, I would just use the rest of these input fields. But in this case, I happen to have been dimensioned an endpoint, so it's 3¼ by minus 0.671. Now, when you fill it out, it's going to show you, in this case, potentially two results. In an arc, with that, since I'm not stipulating the center point, I have two possibilities. So what you're going to do is you're going to use the dialog select to pick whichever one you want. You want to pick it by making it orange. Once you've selected the arc that you want, just hit the dialog select function in the lower right corner, and it'll save now all the calculated data for this arc, where the center is, starting angle, ending angle, that kind of stuff. From there, I can accept the arc, and I see it starts to draw the arc. Now in this shape, I'm coming down with a 2-axis move. I'm moving over to 4 inches. I'm coming down to 1.802. We accept it. Now I move down. If I had been dimensioning the angle, I could have certainly inputted the angle here. Now we're moving down in the Y, straight down. Now there is a chamfer at this bottom corner. If you were to look back at the print, we see there's a 45-degree chamfer of 1/2 inch. So what I can do with that is I can simply tell it to move down to a Y value of -3, which would be that lower corner. And at the end of that move, I'm going to say blend a chamfer or a radius of 1/2 inch. Now, I don't see the chamfer yet. I won't see it because I need to have some element beyond this. It needs to know what direction the chamfer is going. So now I'm going to give it a move in X. I happen to be going back to a +1 inch. So I come over. Now you see, I get to +1 inch. Chamfer gets drawn on for me automatically. I'm going to do a 2-axis move on this shape now. I'm moving to X of 0, but a Y of -1.5. Accept it. Now this last move is going to close my contour. So I have two options. A vertical move to end up at Y0, or if you expand over, we also give you a close contour function. That will just complete it for you automatically without you having to type the value. Once you've filled out the contour, and your contours don't have to close, you can be open. You know, if I had a case where there was a clamp in the way or something, I could have stopped at the end of this slope and it would have just jumped over that position. But in this scenario, I let it machine all the way around the shape, so I'm going to close the contour. So I filled out the shape, I hit accept. Now I get the profile. Now I have to tell it what I want to do with it. So under contour milling, I have a few options here. I can do path milling, which is what we're about to do, and that allows me to walk around the outside of a shape. But I can also have treated this as an irregular pocket. So any shape that I draw, I can do that pocket. If I need to have islands, I can now create additional drawing shapes, and they'll all link or chain together, islands or pockets with islands in them. Now let's say I want to leave a boss standing. I can do the same scenario with our spigot cycle, and that allows me to draw a shape that represents the outside boundary of my stock, and then a second shape that represents the feature that's bossed, and then I'll see the tool come in and physically machine, giving me an optimized cutter path of only machining where it would be engaging with the material. But in this example, we're just going to do a basic path mill. First question within the path mill is, what do I want to use for a tool? So I'm going to go to Select Tool. It's going to put me over to my tool table. Now, here we're going to create a new tool. So I want to come down to some empty area. Doesn't really matter where I want to put it. This would be the location it would end up being in the carousel. Some systems don't allow you to create tools right within the tool changer, and that's okay. That would be more of a restriction based by the builder or the designer of the machine tool. So there what you'd do is you'd come down and you'd create tools in an unloaded state. That's just telling us that the tool isn't physically in the carousel yet. And then you'd follow some basic procedure or process for getting the tool physically in the machine tool. But in this case, I want to just create a new tool here. I'm going to tell it I'm doing an end mill. So we're going to do a cutter, and it'll automatically default to some name. I can delete this. I can type it in. We're using a 1.25" end mill or cutter. So I type that value in for my own name. Length here, that'll get set when you act. I'm going to tell it the cutter diameter and then the number of flutes. So we'll say that this is a 4-flute cutter. I've created the tool. I'm going to tell it to program. To program is now going to fill out the tool information for me inside of the part program. From there, I'm going to come down and give it some feed rate. Say I want to run 50 inches per minute at an RPM of 2,500 RPM. Now, if I wanted to program feed per tooth, I do have that option. Since we define not only the diameter in our tool table, but the number of flutes, I can physically type in feed per tooth, and it'll calculate out whatever feed rate I want to run for that. Next, we're going to come down to our machining state. That's that little diamond right here, and this tells us whether we're roughing or we're finishing or we're chamfering. So we get a few different options we can do on this profile. I want to rough it out, so I can take multiple passes on it. I can define, do I want to follow the direction the shape was drawn, or do I want to go the opposite way? Well, in this case, I already drew it clockwise, and I want to climb mill, so I'll follow the direction I drew it. The next little indicator down here does define cutter compensation, left or right, or no comp. I'm going to use cutter comp left. Then I tell it the top of the part, the overall length or depth. So this part happens to be 1/2 inch thick. My depth per pass, maybe I want to take this in 2 cuts, so I'll do 1/4 inch per pass. And then do I want to leave finished material, first in my Z and then in my XY. I'm not going to worry about leaving any finished material in this example. We'll just bring it to size. Then I need to define, how do I want to approach the shape? Do I want to lead in a straight move, a quarter circle, a full semicircle, or if I'm using cutter comp and I want to follow the path, I can use a vertical. In this case, I'm going to do a straight, give myself some basic line length move. I'm just giving it 1 inch here because I have some room, some feed rate that I'm feeding into the part, and then how do I want to get off it? I get the same options as well. So once I define that, I'm going to select my final option, which should be, what do I do when I'm done? And then doing between passes. So this could be how I control if I didn't fully close my shape, if I want to jump over a clamp, or if I want to stay down, or maybe I don't want to retract at all. But I'll let it retract all the way back. I select accept. My contour now changed to my path. At this point, it gives us a good chance to first take a look at our simulation. So we can jump over to simulate. Then we can see us walk around the shape. All right. The next step would be to come back and put in our drilling. So I'm going to go to drilling. I'm going to pick a basic drilling cycle. this case I'm going to do a peck drilling cycle. I'm going to go grab a tool. Now here I'm just going to use a tool that I happen to have already created. So I'm going to use this 1/4-inch drill that I have in my tool list. I fill it out. We're going to give it some feeds and speeds for the drill. So maybe I want to drill at 10 inches per minute at say 1500 RPM. Do I want to use a chip breaker or chip removal, so peck drilling or chip removal? Do I want to compensate for the tip of my tool, or do I want to program based on the tip? And then you define some depth. So, if I was doing a 1/2-inch plate and I wanted to just break through, I could say compensate for the shank. I want to tell the machine in absolute to go down 1/2 inch. And what will happen in this case is it'll physically go down 1/2 inch plus whatever it calculates the tip to be. When I created the tool, I told it the tool angle for the drill. You have your pecks, whether you want to decrement your feed or your peck amount as you get deeper in the hole, especially works well for deep hole drilling, how much I want to back up, and a dwell. We accept the feature. Now I want to just link it to some basic positions. Here I can go into our random locations, and I can stipulate these 4 holes. So my first hole is 5/8 over, oops, typo, and 5/8 down. The next hole to my right is going to be 2.125 over, and I'm not moving my Y, so I'll leave it blank. Now we're going to shoot down to the lower right hole, so I'm going to say that is a X of 3 and a Y of minus 2.375, 2 3/8, and we will finish back at 1.5 and X. So if we accept this, we do a quick simulation, we should now see our profiled part with our drilled holes. There are our 4 drilled holes. You can see we can look at it in 3D, we can zoom into it, I can rotate it to any shape, we can go in, we can cut the solid if we wanted to. This is kind of what we were seeing a little bit before in the PowerPoint. So this is how I would handle a job like this if I was doing it conversationally. From there, if I was ready to, I could simply hit the execute button, brings me over to auto mode, I can select cycle start, now the machine would run as if it was running, if it was physically making the part. We have an option here, I can bring on what's called a simultaneous record, so I could have turned on our graphics and then ran it, and then I would see live while it's cutting in 3D as well. All right, so that would be our first scenario for creating a part. Now, the next step would be, well, what if we wanted to physically do this part in G-code, in Program Guide? So what we're going to look at next is we're going to look at methodizing or programming the exact same job, but we're going to do it in Program Guide or G-code. And you can kind of start to see the similarities and the differences between the 2 operating modes. So here's a quick example of what the editor will look like. We'll see that in a second. Then we have our cycle support screens you're going to get to see, and that's basically what we have is we have conversational help within our G-code. You'll see that we still have a contour editor for doing irregular shapes, so you can see that all this is very similar to what you just saw. And then the graphics, and this is key. No matter how you create a part program, conversationally, G-code, you bring it in from a CADCAM, you'll notice that you're verifying it and then running it in the exact same modes, which is unique to us. A lot of times, control may give you the ability of solid modeling in one area but not the other, or maybe it has a whole unique area to run its conversational programs outside of where you'd normally run G-code. Here we try to keep everything universal. It just makes it much cleaner and simpler for an operator to learn. So we're going to jump back to CineTrain. I'm going to go back over to Program Managers just like we did, but now I'm going to create that same sample by selecting New, but pick Program Guide as opposed to Shop Mill. So I'm going to give it the same name, Sample 1, but I'll call it PG for Program Guide. So I type in the name, I select OK. Initially you would think it looks the same, but remember I didn't have that header screen that I had first filled out. This is a standard G-code editor. I can just start typing text right now and creating a program. But you still have the vertical soft keys and the horizontal soft keys here to be able to do additional functionality. And so we're going to start to use some of these. So first step, just like a very traditional G-code program, I'm probably going to want to tell the machine that I'm in an absolute mode, what work coordinate I might be using. If I'm in inch-metric mode, this will be our inch statement is G70 for our protocol, and what native orientation my tool is in. The next step, I commonly do is define what the workpiece looks like. That would be my blank. Now normally that's set up in the header of ShopMill. Here we have an individual function under various called blank. Blank allows me to do the exact same thing I did before, defining what the shape looks like for graphics, filling out the same values I would have in conversational, but it now stores it as this event. From there, we can go back to edit. I can maybe do a tool change. So I can go select tool. Now, when you're doing G-code within our control, and we'll just grab this tool, this 1.25 inch, if you're naming the tools, this naming protocol like we allow you, the tool call is going to look a little different than you're used to. It's going to read T equals, under quotations, the name of the tool. Now, what if you were doing a tool that you named a physical number? Well, then you don't have to do the T equals statements. Here you would just do a T1 or T2, and that would call up tool number 1 or tool number 2. But I'm using that protocol, so I'm going to type it out. So I'm going to use that T equals quotations in the name of the tool. Next thing I want to tell it is that I'm going to use cutting edge number 1. Unique to us, we allow you to create up to 9 different offsets for every tool you create. And those offsets can be completely unique. So whether you're using gang-style tooling, function tools, like a drill, countersink, counterbore style tool, and you want different offsets, you can do that. Tell it to do a tool change. Very typical would be an M6 command, but that functionality is kind of up to the OEM, how he wants to fire his tool changer. At this point, maybe I want to fire up my spindle, maybe start turn some coolant on, so maybe I'll tell it some spindle RPM, 2500 RPM, give it maybe an M3 for spindle. We do allow multiple M codes on the same line. You can do, I believe it's up to 7 M codes per line. So here I'm going to fire up my spindle and my coolant in one shot. Then from there, I'm going to tell it, am I doing inch per minute or inch per rev feeding? We do allow feed per rev in G code as well. You can do a G95, or there's even a unique command if you want to program feed per tooth within the system. But I'm just going to do simple inches per minute, 50 inches per minute. And now we're going to go in and we're going to start creating our contours or our shapes. So just like before, first thing we did was we walked around and profiled out our part. Now what I am going to do initially is I'm going to put an end of program statement, because this is where there's a slight difference from conversational to G code. What you do is you create the shapes the same way. I go to contour mill and I go to contour, and I'm going to do a new contour, but I'm going to build them, and you'll see how it comes out in G code, below my M30. I'm going to let them be at the end of my program, and then I use this contour call when I want to actually run them. So I'm going to go to new contour. I'm going to type in the same name. The name again doesn't matter. I could use a completely different name at this point if I wanted to. I type in profile. I hit accept. From here you'll notice it's an identical editor. So I'm going to use the same functions I did before. You know, I'm moving over to some X value. We're going to sweep around in an arc to some radius, 1.5. Where am I ending? I'm going to end at 3.25 minus, I believe it was 671 down. Gives me my 2 options for my arcs, just like we saw before. So everything is identical at this point between conversational or program guide. I'm going to do a 2-axis move, so I'm going to end up at X of 4, a Y of minus 1.802. I start to see a draw. Maybe I'm moving down here to my minus 3. This is where we did that chamfer before at the lower corner of 1/2 inch. We accept it. Now I'm going to move back, in this case to 1 inch. You see it's continuing to draw just like we had before. I'm going to do a 2-axis move to X of 0, minus 1.5, accept. And like before, I could either use the close contour function or just do a line move up to Y0. Either one does the same function. So I've drawn the shape, I close the shape, I hit accept. So now you see it created this E-label profile. The profile is the name I gave it. And if I look at this, I scroll down a little bit, you can start to see this is just the way the contour editor creates the geometry. Just builds it in these little labels, and I just nest it below the M30. So now above the M30, when it's time to start to use the contour, all I do is use a contour call, because I could potentially have multiple profiles down here. So I'm going to use a contour call statement. I'm going to define the name, whatever I called the contour, and that will create this cycle 62 statement. So this is how our cycles work. Anytime you create any cycle, you open it up and there'll be what we call a data masker, basically an interface field that allows you to edit the cycle really conversationally. So we have our cycle 62 profile call. Then from there, if I back out, you're going to see the exact same functions you had before. Path milling, pocket milling, spigot milling, it's all the same scenario. Now you'll notice as we go through it, there's a couple different variables because there are certain things that conversational knows that it may not know here. So for the path milling, first thing I got to tell it is my orientation, because normally that is handled outside, but we can't assume in the cycle that that was done for us, or we know it was done. Retract plane and safety distance are both values that we found in our header page of shop mill. Since I don't have it, I have to put it in the cycle. So it's just a couple extra fields. Feed rate, am I roughing, am I finishing, am I chamfering, all the same functionality we had. Forward or reverse, what's my cutter comp, left or right, or no cutter comp. And then it's really just filling out the geometry. What's the top of the part? Is it Z0? Is it some other positive or negative value? What's the depth that I'm machining to? What am I going to do per pass? Am I leaving any material for a finished cut? How do I want to lead in? Just like before, straight, quarter circle, semicircle, vertex. And then how do I want to leave out? And do you want to retract? I'm going to do a no retract in this scenario. So I hit accept, builds the cycle for me. So at this point, I can hit simulate, and we can start to see that we're going to get the exact same profile we saw before. So here I see I'm walking around, but now it was programmed in G-code as opposed to been programmed in conversationally. Select edit, brings me back. Now it's time to do a tool change. This is where there's some slight differences between here and conversational. Here I would treat this more like a very traditional G-code program. So first things first, I'm probably going to want to maybe shut my spindle off with an M5, maybe shut my coolant off. Then maybe I want to do some kind of reference return. A lot of us are used to maybe like a G28 type of command. For us, we use a command called SUPA, S-U-P-A. And what that does is that temporarily suspends my work coordinates, but this is a non-modal instruction, so I don't have to reload the work coordinate after it. And it allows me to position based on my machine coordinate locations. So in this statement, I'm saying cancel all tool offsets with the D0 because I don't need them now. Put it into a rapid mode with a G0 and send Z all the way to machine home, which should be the Z extent of its travel all the way up top in a plus direction. Next thing would be to do a tool change. So I'm going to go select tool again, come down, find my 1/4 inch drill. You'll see I'm still using the T equals quotation statement. I'm just going to call it cutting edge number 1 by D1. We'll do an M6 to tool change, and I could have the M6 on the same line as well. Then after that, we're going to fire up my spindle. So we'll give it some RPM. We'll turn on my spindle and turn on my coolant just like we did before. All right. Now at this point, I'm ready to go in and start drilling. So I'm going to want to go to drill, pick the cycle. Maybe in this scenario, instead of doing the deep hole, we did the deep hole before, maybe I'll just do a standard drill reaming cycle. So I pick the cycle, I tell it my retract point, my safety distance, or what we're used to calling the R plane. What do I wrap it to within the part? And then we have an option. We can do a single position, so wherever she's sitting right now, it'll drill a hole. Or I can do a position pattern with what we call an M-call statement. Once you do that, since we are doing multiple positions, you define what's the top. So what am I starting my drilling from? In this case, Z0. Am I programming based on the tip of the shank, just like we saw before? What's the depth I'm drilling? And do you want to dwell at each hole? Once you've filled out the page, in this cycle with drilling, it's going to feed to depth, then wrap it out. If I was doing a reaming, it would feed down and then feed back out for me. But we're just doing basic drilling, so I'm going to hit accept. So what do we see here? Well, we see this M-call cycle 82. So again, at any point in time in any of our CAN cycles, when you see it highlighted and you have this little arrow to the right, that means if I arrow over my blue keys, I can open the cycle and make an editing change. From there, I want to tell it my positions. So I'm going to go to a position screen. I could also just give this XYZ locations. I'm going to give it my random locations that happen to have been here from last time I created this. So I'm just going to hit accept. It gives my locations. Now, just like we're used to in cycles, whenever you turn it on, it's modally on until you shut it off. So a lot of us are used to a G80 statement. For us, it's just mcall again. So the M itself disables drilling. And from there, if this is the end of a program, I might want to shut off my spindle with an M5, shut off my coolant. Maybe I'll do my SUPA. So there's your SUPA cancel tool. Put it into a rapid. Maybe send my spindle all the way up. From here, table. So let's assume that we have a machine that has 40 inches of machine travel from machine coordinate home is in the negative. So I could put minus 20 and a y of 0 to bring the table center. And then from there, I end the program with my M30. I go to simulate, and we're going to see that we have an identical path to the program we've previously just created. So the graphics are all the same, 3D, rotated all around. I can certainly go into my zoom function like you saw before, technical simulation mode, just working within the G-code side of the control. From a running standpoint, I would put my highlight to the beginning of the program, select execute just like I did over in conversational. Notice that the program will look different, but you're in the exact same function or the exact same mode, which is our standard auto mode. So here I could cycle start it. It would run through my program. I have the ability of doing the concurrent verify, the simultaneous record as well, just like we saw before. Okay. So with that being said, let's jump back to the PowerPoint real quick. What we're going to do is now we're going to start to look at the exact same shape, but it was imported from a CADCAM. How do I handle it? How do I edit it? How do I get it into the control? And we're going to look at the editor function. We're going to look at the cycle support screen, even though it was built out of a CADCAM system. We're going to add in a block form to it, especially if your CADCAM system can't handle that. This way you can use a solid modeling graphics. We're going to show you how you can both wire verify the shape. They do the exact same scenario where we're bringing it over to run mode, cycle start it, let it run. Okay. Good. So with that being said, I'm going to go back to Program Manager. We are now going to go get this program. It exists somewhere. So we're going to say that my local drive, which happens to be my docs on my PC, we're going to treat that as if it was the network. So your programming department created this file, you created the file, you posted it on some folder somewhere. So the operator or you would physically just select the network drive function, folder, if you wanted multiple folders, or just in a base root folder. Highlight whichever file you want. So in this case, I'm going to grab this CAM file. You can open right here. I can click my right arrow over. I can see what the file looks like. I can do this here if you expand over the vertical soft keys and go to Mold Maker View and see of what the part program, I can even get an idea of if it's the one I want. You can edit here. You can even run if people never even bother copying internal part program memory. They solely leave it on their network and run it. It'll just be a matter of execute, and I'm running from the device. But for what we're going to do, we're over. So I'll physically highlight the program, click copy, go to my NC, whatever folder I want to be, click paste. Now I have that file is residing on my machine tool. We can again just hit the arrow over key or the open button thing, and I can go into the program. Now this would be a very traditional CADCAM style program that you're looking at here. Basic user notes. We got some very typical that CADCAM systems have a hard time names for the tool. So if you're limited to that, you're just, when you create the tool table, you're just going to call it the number 1. So I would create the tool the exact same way I did before, but instead of giving it a name, I just give it a number. So that, call it in the part program, everything's happening. You'll see some unique to us. One that's a corner, basic feeds and speeds, and the shape of this part. What we have down here, then we'll tool change to tool 2. Drill. Now, in this case, we have a system supporting our cycles. So it's posting our, this is where it's kind of neat. Even though it was posted, I can actually open it up and edit it conversationally on the control. As far as we're concerned, we have no idea whether that cycle was written at the control or written externally. So if I come in, I'm posting things at a CADCAM, and we want to make a quick mod because we're not quite breaking through all the way on a drill depth. You can edit it, minus 0.650, accept it, made the appropriate change. Here we see my updated in the cycle. So it's really important to get your posting or outputting our protocol with the CAN cycles because it adds abilities within the system. So at this point, I do not have any kind of a block form in this program. The system would have I'm in this scenario, this CAN package of outputting the block. So what would happen now if as long as I have the wireframe mode turned on, or the show path mode, it'll just simply give me a wireframe. So I can machine it or take a look at it from a wireframe format. That's turned on and off by expanding your vertical keys over and clicking on show path or not. What if I want to have a blank here, but I don't want to put a block form in the part program? You do have this blank option, and what that does is it allows you to fill out the variables, hit accept, and I can still graphically simulate it with my solid model. So even though you don't have the blank or the block form in the program, not limited, you can still view it as a solid. The downfall here, if it's not in, every time you come back to simulation, blank, because if not, it's going to just do it as a basic wireframe. So here it comes back in, and again, you just see the simple wireframe. So with that being, if I want to add a blank, you can certainly do that. And this is a quick little example of how we can start to edit our CADCAM files. The machine tool. Here maybe I want to make a space here. Usually what I do is I add the blank, and it's the same spot as it was when we did program guide. So under various, and I put a blank. I usually put it right at the top. So I come in, I fill out the blank just like we did before, I hit accept, and it gives me this workpiece blank. Now there are plenty of CADCAM package protocol and have the information. And if you're developing a post for the system, that you can have a guide within this system. What's nice now is I don't have to go back to that blank option. I see the blank immediately, and away I'm running this CADCAM posted file. So from there, just like we were in program guide, I can jump right over to execute and run it as if I was running any program. So I can cycle start, I see it as it goes. We can use a simultaneous record if we want, and we would see it as it runs. My overrides are all live now, so if we're rerunning, we were going fast before, I can certainly slow it. This is quasi real-time. You know, the simulation, or shall I say the CineTrain software we're looking at, it doesn't know. It's not physically hooked up to a machine tool. As far as it's concerned, it might as well be. Oh, so that would be the CADCAM if the CADCAM was posted for our machine tool. Now, this brings up a very good question. What happens if we're putting a machine in, or we have a machine in, and it's a job shop, or it's a customer that has a lot of FANUC style or FANUC programs or FANUC machine tools? So what we've done here is we've incorporated a system within that allows us to bring FANUC programs, CAN cycles and all, right within the system and run them just like you'd run any other part program. That's what's called our ISO compatible mode, or our ISO mode. So there's two industry standards kind of within the industry as far as protocol of programs. You have ISO, which is the protocol that FANUC and a lot of other typically Asian builders tend to follow. And that has to do with how the program's denominated and some of the back-end functionality and how they work. Or there's a DIN protocol, and we happen to follow the DIN protocol. That's why our program structure kind of looks and runs the way it does. It's just a different methodology. But within that, we have this ISO mode. So now the way this works is you're simply going to put a G291 command anywhere within the part program, but it has to be just prior to the FANUC protocol. So the whole program doesn't have to be in this ISO protocol or this FANUC style. You can do pieces. You can do our code, then theirs, come back to ours, or you can do the whole program if you're just bringing jobs over that were previously programmed for another machine. Now, there will be some changes to your tool table that need to be addressed, so we will talk about that in a second because we're following the FANUC protocol. You can make editing changes. We can still do a block form if we want to. We just have to make sure we set that up prior to our G291 command. We'll be able to go in, just like we did before, and simulate it. So even though it's a FANUC style program, we can still go in and graphically run it. And then we'll be able to go over in auto mode and physically run it through its paces. So with that being said, we're going to jump back to a live demonstration here. And we're going to go back to Program Manager, and we're going to treat it just like we did with the CADCAM. So we're going to assume that it's sitting in the machine tool. In this case, it's on my fictitious network directory, we'll call it. I highlight the physical file. I can edit it here. I can open it here if I wanted to. Or I can just copy it, put it into one of our directories or a folder. It really doesn't matter. Paste it, and now I'm going. So this would be traditionally how you would see the file possibly come in. A lot of times you will see like an O and a number. We don't need that. You would take the O number off. But other than that, this would be a very traditional FANUC protocol. If we come down and we take a look, our M6 string, our G43H1 to call up our height offset for tool 1, our G41 with the D protocol call to call up the diameter of tool 1. If you scroll down in the program, this one happens to even be using a G81 drilling cycle to drill its holes, and then its basic coordinates, the G80 to cancel the drill, G28 for reference returns. So this is your very, very traditional FANUC protocol. So what do I need to do? I need to do a couple quite slight modifying or editing changes. First thing I want to do is add a G291 to tell the system, hey, I'm going to be in this ISO mode. Now, personally, and you don't have to do this, but I always instruct people, when they get all said and done, just before their end of program, put it back to our mode. Our mode of protocol is G290. So do that as your last statement. This way, you don't get caught up on maybe some other function not working because it's still in this ISO mode. There are certain things our controls can do that they don't do or they don't support. And when we run it in their mode, or the ISO mode, we have to comply with exactly the way the FANUC runs. So if there's maybe an advanced function we have, you won't be able to take advantage of that while you're in that mode. That's why it's good to shut it off when you're all said and done. The other thing I always recommend to people is don't use this mode if you're going to develop a post. It's a very easy crutch to get into to say, hey, I have a FANUC post already. Let me just add a G291 to the beginning and end of the program, and I'm good to go. There are plenty of advanced functions within our control that give us pretty high-level capability. The problem is if we're only ever running in this ISO mode, we can't take advantage of them. So you're not really using the control to its full capabilities, especially when you get to complex machines, 5-axis machines, multi-technology or mixed technology machines like turn mill or mill turn. Those are areas where, use this sparingly. You got a bunch of part programs, you want to rerun them, great. But you want to get to using our advanced functionality to get the most out of the system that you just bought. So now at this point, with the G291 there, really that's all that would need to be done. I can immediately jump over to simulation. We could simulate it. Now again, there's no blank currently, so I'm just going to get a simple wireframe, just like we saw before in Program Guide. We see our drilled holes. It's done, goes to some reference location. I do have the option of turning my blank on here if I wanted to. So I could turn it on and still simulate in the 3D simulation, just like we saw. Again, identical to everything we've done so far. Or the other thing I could do, which is usually my preferred method, is just prior to my G291, I'll put in that blank. And again, remember, you can intermix this stuff. So as long as I'm above the G291, I can give it a blank statement. If I gave the blank statement below it, it would say, hey, that's an unrecognized command, because ISO doesn't have that command, but we do. So here, by putting in that protocol, I jump over to simulation, and you'll see it'll just bring the solid model up for me immediately, roll around the part, just like we saw, and continue going. Okay. Now at this point, just like we did before, if it's time to run, I can simply hit the execute function. It'll load it in. You'll notice the program looks identical to the way you just brought it in or worked it. So as I cycle start and I run it, it's going to look line by line, code by code, the exact same way. We're not doing anything. We're not parsing this. We're not converting it into our protocol. As far as you're concerned, it's running this exactly the way you brought it in. I can crank my overrides up here. Maybe I want to do the simultaneous record. I can do that as well with my concurrent graphics. So really pretty much any way you're running it, any way you methodize it, whether you do the ISO mode, CADCAM, G-code within the control, or our conversational, you can run it, edit it, and it's all going to be in the same exact interface. Makes it much easier, simpler for your operators. Because now, hey, maybe you got some files that are coming out of a CAD-CAM package. Maybe you got some that you're going to let them write right on the machine. They don't have to learn a whole different section of the control. They don't have to learn new simulation. It's all the same. So with that being said, I want to take a quick second to thank everybody for having joined me for these 3 webinars, and I'd love to open up to the floor to see if we have any questions.
We do have a number of questions, Chris. First, is it possible to upload a program created in FeatureCAM 2012 to the Siemens 810 control?
Sure. I mean, there's absolutely no reason why you can't upload a program out of any CAD-CAM package. Your limitation is really whether that CAD-CAM manufacturer has developed a post for the system. That is always a responsibility, certainly, of the CAD-CAM company, because all the post is doing is taking their program and translating it into an equivalent protocol within ours. But yeah, there shouldn't be any reason why you can't get a post out of that version.
Okay. And then this one, I'm not quite sure I understand what's being asked, but I'm going to try my best here. If you need to follow an equation for a contour, a mathematical equation like a combination of sine and exponential function, what would the procedure for that be?
Well, we do full parametric programming, so you can certainly define variables within the system. You can do mathematical formulations to compute data points. So I think that's probably what they're asking. So then the question would be yes, via our parametric style programming, which is similar to what you might see on other systems. Which tends to be a little bit more robust. We followed more of a true programming protocol with gold, that kind of stuff. But yes, we can do equations and formulas and that kind of stuff.
Okay. In a shop mill program, can you program a reference return like the super command that you used in G-code? Can you do that in shop mill?
Sure. And actually, I can show you. It's kind of neat here. If I just jump really quick back into CineTrain, we're going to go back to our program manager and open up our shop mill program. Now, what you can do here is you can intermix G-code with conversational. And a lot of systems have trouble with this. For us, it's just a matter of clicking the input key, gives you a G-code line, and then I can literally type instruction just like I did before, my D0, G0, and maybe a Z0. And that would instruct just like you saw in the G-code. So that would be the simplest way. There's other ways conversationally do reference returns, but if you want to use the super command, you just use it that way.
Okay. Another attendee wants to know, can you solid model special form tools and then import those tools into the Sinumerik for simulation?
No. As far as the tools in simulation are concerned, you are limited to the tools that we have. Now, with that being said, we have a pretty robust library. So, if I come down and maybe I come to an area where I want to do a new tool, these are your base tools, simple end mills, face tools. But if you go in, you can even dig deeper. So we, in a milling scenario, we support beveled cutters, corner radius cutters, die sink type cutters, bull noose, conicals, but you are limited. The drills, we have all sorts of different drill profiles. There's some special tool functions for probes and slotting saws, but you are limited to the tools within this library here.
Okay. When you're posting a program from CAM, can you use cutter compensation to adjust the wear of an end mill?
Yes. What will happen here is in the CADCAM file, and I want to say, I think I even have it in this one. Right now, they didn't have cutter 40. If you're using it, like this was centerline of the cutter, you can certainly put a G41 statement for your cutter compensation. The only thing when you're using it for wear is it's now going to need the diameter to be set to a 0 or a small incremental value. So what it will do is it will mess up what the solid looks like because we're looking for that diameter. So although you can certainly do it, potentially you're just, when you simulate it, it's going to look like you're either offline if you have the full diameter. See there, I'm way off the part, or if I zero it out, I won't get the tool represented. So that's
okay. When you use the FANUC compatible mode for turning, is there any way to select what protocol of G code the system is reading?
yes. Yeah, there's actually, when it comes to FANUC, they have 3 different protocols they followed over the years, kind of as they grew with the control. They had FANUC A, then they went to FANUC B, and now they're at FANUC C. You don't have that issue in MIL, so I didn't have to show it, but we do have a back-end parameter that you would set up, so however your programs are coming in, A, B, or C, you would just make sure that that back-end parameter is set to it, and then we'll read that.
Okay. Is it possible for my CAM system to output the block form information?
Yes. It is a limitation of the CADCAM package. You'd certainly have to find out from them. But as far as we're concerned, this is just a text string. So really, they just have to make sure that it reads the way this looks. And then from here, just have a couple basic variables. They'd hard code in a box, and then they would really just be putting the opposing corners and then the thickness of the shape. So they could certainly write that. In fact, I know MasterCam can certainly do it.
Okay. Thanks, Chris. Looks like we have time for just one more question before we conclude here, and that is, can you use the ISO mode for 5-axis programming?
Like I kind of said earlier, you want to be careful with ISO once you get to any of the higher end technology, specifically when you get to 5-axis. There are limited functionality we support within FANUC's protocol. We do like their rotary workpiece compensation and whatnot. But when you get to true 5-axis simultaneous cutter path, then I would certainly recommend you stay to our protocol of G code using our commands. So it's limited. Be careful with it.
Okay. Well, thank you, Chris. That concludes part 3 of this instructional webinar series from Siemens. Everybody should note that this webinar has been recorded, and you'll receive a link to that recording in your email in a couple of days so that you can reference it later. Thanks very much to Siemens for providing this information, to Chris for his wonderful job presenting it, and thanks to all of you for attending. We hope you found it valuable. Have a great day.